It feels like almost overnight, AI assistants just got good, right? One minute they were these clunky, kind of unpredictable things giving you weird answers, and the next, bam, they're drafting emails, writing code, and explaining things with, honestly, stunning clarity. Well, that wasn't magic. It was all thanks to one revolutionary paper that taught AI not just to predict the next word, but to actually understand what we want.
So what was the secret sauce? How did researchers finally crack the code to make these AI models genuinely useful? Well, the answer lies in tackling this one huge fundamental problem that was holding the entire field back.
See, before this breakthrough, the main strategy in AI was pretty simple. Just go bigger. Build bigger language models, feed them more and more of the internet, but researchers were hitting a wall. Just scaling things up wasn't making the models any better at following our instructions. In fact, a lot of the time it was just making them stranger.
And hey, don't just take my word for it. This quote comes straight from the researchers at OpenAI. They knew their massive models had a big problem. They could sound super fluent, but they might be totally making stuff up, saying offensive things, or just completely ignoring what the user asked for. This was the core challenge, and they gave it a name: misalignment.
So what exactly is misalignment? Okay, think about it like this. A normal language model is trained on just one super simple goal: predict the next word in a sentence. That's it. But our goal as a user is totally different, right? We want answers that are helpful and truthful and, not harmful. The AI's objective was just completely disconnected from our human one.
So to fix this, the researchers came up with this really elegant and powerful idea. They thought, instead of just dumping more books and websites into the AI, what if they could get direct feedback from the one source that actually knows what helpful means? Us, real people.
And here's the core idea. Use human preferences as a direct reward. So imagine you show an AI two different answers, and you have a person pick which one's better. That choice becomes a signal. It's like a virtual thumbs up that teaches the AI what good actually looks like from a human point of view. This whole method is called reinforcement learning from human feedback, or, as you'll see everywhere, RLHF.
Okay, so that sounds great in theory, but how did they actually pull it off? Well, the paper lays out this incredibly clear three-step recipe. It's a process that mixes traditional training with this brand new way of learning directly from us. Let's break it down.
This process, RLHF, is this powerful combo of human guidance and pure machine learning, and it all boils down to this three-step cycle that you're seeing here.
Okay, so step one, human labelers act like teachers. They literally write out perfect, high-quality answers to different prompts, showing the AI what to do. Then, in step two, the humans become judges. The AI generates a bunch of answers, and the humans rank them from best to worst. All of that ranking data is used to train a separate AI called the reward model to basically develop its own sense of taste, to copy the human judges. And finally, step three, the original AI starts generating answers, and it gets a score from that new reward model. It then fine-tunes itself over and over and over, essentially just trying to get the highest score possible for being helpful and safe.
So, did this whole complicated recipe actually work? Oh yeah, the results weren't just good, they were absolutely shocking. They completely flipped the script on what makes an AI model powerful. Turns out, size really wasn't everything.
100 times. Just let that sink in. This one number represents maybe the most stunning finding in the entire paper. It stands for a massive, massive leap in efficiency. But what is it actually referring to?
Well, here it is, a model with only 1.3 billion parameters. And you can think of parameters as kind of like the model's neurons, was consistently preferred by real humans over the gigantic 175 billion parameter GPT-3. This was the proof. The alignment training was way more valuable than just raw brute force computing power.
And this chart just makes it crystal clear. The preference score for the little InstructGPT model just towers over the massive GPT-3. It was a complete paradigm shift. Smarter training beat bigger size, hands down. It wasn't even close.
And it wasn't just about what people preferred. The models got so much safer and more reliable. Just look at this. The rate of hallucination, which is just a fancy word for making up facts, was cut almost in half. Toxic outputs went down, and the model was rated as being twice as truthful. This wasn't just a better model, it was a much more responsible one.
Now, this paper wasn't just some dusty academic exercise. Its findings and its methods were put into practice immediately, creating this bright, clear dividing line in the history of AI. The techniques that pioneered here are now the absolute foundation for the AI assistants that millions of us are using every single day.
You can see that dividing line right here on this timeline.
Before 2022, large language models were this powerful but kinda niche tool for researchers. Then, boom, the InstructGPT paper gives everyone the recipe for alignment. And right after that, we see the explosion of helpful AI assistants that are now just a normal part of our lives.
I mean, this new level of reliability just unlocked so many things. You can't really have a customer service chatbot if it's constantly being toxic or making stuff up, right? You can't rely on an AI to write computer code if it's just guessing. This alignment technique was the key that made these tools practical and trustworthy enough for the real world.
So if there's one thing to take away from all this, it's this. The InstructGPT paper proved, without a doubt, that how we train an AI can be way more important than just how big it is. Quality of training, aligned with what we actually want, is so much more powerful than brute force scale.
But this whole thing leaves us with one final and really crucial question. This entire process is built on aligning an AI to the preferences of a small group of paid human labelers. So we've succeeded in teaching AI to follow our instructions, but who gets to decide what those instructions should be? As this tech gets even more powerful, figuring out what is helpful and harmless for all of humanity, well, that's the next great challenge.
This is for entertainment purposes only.